All right, looks like the attendee joining list has slowed down, so I'm going to go ahead and get started. I'll say good morning or good afternoon, depending on where you are in the world. I guess I could say good evening too. I'm not sure where everybody's coming from. I'd like to thank everybody for joining me in my Midwest University speaker presentation. I did teach this back in Revit or back at Midwest University 2018. So I thought I'd pull up the old PowerPoint slide just so you know I could be lazy and not have to recreate the PowerPoint slide. But this session is going to be all about Revit and how I deal with slope framing, multitude of ways to do this. One thing I do always like to encourage is ask questions as we're going through. So we are on a Zoom meeting here. So you guys do have the chat pod and the question and answer pod. So if you do have a question, I please ask you guys type it in the question and answer pod. A lot of times I'll deal with those as we're going through because I like to answer the questions if they're pertinent to what I'm doing as they come up. But if you want to heckle me, or if you want to go through and heckle everybody else, or even suggest tips or tricks on what I'm currently showing, feel free to put those in the chat pod as well. That's what we have the chat pod for. And if you are in the chat pod, you might notice down at the bottom there is a let everyone know or just to the host and panelists. So if you want to heckle just the hosts and the panelists, you can put it in there. Or if you're going to give a great tip or suggestion, feel free to put that in there and send it to everyone. So that said, I'm gonna jump into it. I'm Brian Mackey. I have been presenting at Midwest University since I think the very second one they ever had. I missed the first one. It's a great session. I always like to do it, and eventually, hopefully, like everyone else, I hope it does go back to live. But my background was in construction. I went to school for construction. I ended up being an architectural mill worker for quite a few years. Worked for architects for a few years, and then I got into the Revit consulting industry. I worked with an Autodesk reseller, and then went out on my own back in 2011. So I've been using Revit since 2004, shortly after Autodesk acquired them, and I've never looked back. So I love doing what we're doing. So getting into the slope framing here, we're going to jump into that. I'm going to talk about 3 different types of methods on doing slope framing. A lot of the way people know about the work plane method, go ahead and set up a work plane. You're going to do that one of 2 ways. I'm going to show my theory on the attachment method. And I'm also going to show you some cool things that we can do with trusses. And I always do love this session because I taught this, I think it was in Europe, at Built Europe. And I was giving this presentation on the work plane and attachment. And one of the guys actually came up and said, oh, I do it this way by doing trusses. So it's now part of my presentation, but it was a tip from somebody in the audience. So like I said, if you have something or see something that you're going to get into, or that you're like, hey, this is a great tip you want to talk about, let me know, because hey, it's now my presentation and I learned about it during my own session. So want to talk to you here about some slope modeling and for structure methods mostly, but again, if you're an architect, you can also use some of these same tools as well. But getting into pick a plane or reference plane option for modeling some slope information here. Back to Revit. So I've got a couple different little scenarios here. I'm going to walk through and do each one of those as we go through and set it up. That once I get in here and start setting up, there's a multitude of different ways of doing this, and there are pros and cons to each way. One of the ways to start working on this is to literally create a reference plane or a work plane when you get into this. So I'm going to come down here into the reference plane scenario. And what a lot of people will do is when they go to see setting this up, they might actually grab a work plane and start setting up the work plane when they go through this, right? There's 2 methods of creating work plane. One is to draw a reference plane, which I'm going to show here. And in a minute here, I'll show choosing it just like the underneath side of a roof. So one of the things to me that when you get started, if we go into a section, go into an elevation, any type of vertical view, and draw in a reference plane, right? So if you wanted to set it up, we can come in here, draw on the reference plane. We can go to our structure tab or architecture tab, draw a reference plane, and draw the reference plane where we want that slope to be going. The key thing to me that I always talk about on drawing the reference plane is then coming into that reference plane and giving it a name. You can either give it a name by where it says click to name, or you can come over here where it says name in the properties and say, hey, give me myself a name. Personally, for me, if it's a reference plane that I am dealing with in the project, I go through and say, do not delete, right? That's how I start every single reference plane. So that way, if somebody does select and they go to delete it, they might actually see the word here, do not delete. Because if this work plane, this reference plane gets deleted, then all of your beams become unassociated. So that's first for me. I say, hey, do not delete. And then I'm going to give it some sort of description after that. But now that I've got that reference plane selected, What's kind of cool about this is if I wanted to come over here and start working in that, when you go to start modeling beams, when I go to my structure tab beam, if it's been a named reference plane, if you've given it a name, you can choose that as a drop down in the placement plane in the options bar. If you don't give it a name, it will not display here. So only named reference planes and levels display here. So if I wanted to do it, it becomes really, really nice that I can just start saying, oh, let me choose this reference plane. The other option I'm going to show you where we pick the underneath side of a roof, we actually have to go to a section, pick it, switch views, and go back and forth. But if you have this here, I could use that even in 3D. So if I wanted to go start modeling in 3D, same thing. If I go to the structure command, go to beam, I can now choose that reference plane you'll see as a work plane. In 3D views, it will also give me all of the grids, but here I can start coming through and choosing that same reference plane. So depending on where you want to model, one of the advantages of a named reference plane is the capability to choose that in any of the working views you're in. So I'm going to go through here and do my structure. I'm going to go say do a beam. I'm going to say instead of level 2, go to the roof bottom 2. And then you'll see just like normal, I can start coming through here and modeling this. Now what becomes weird is since that reference plane has been sloped already, when I start seeing this here that says the midpoint, you're like, but that's not the midpoint of the column. What's going on here? Why is that all the way over there? Because it is the midpoint of the top of that column, parallel or perpendicular, I should say, to that reference plane. So it starts becoming really, really weird when you're in here going, oh, I want to be to the midpoint of that column. If you're setting up on a predetermined slope, that this becomes the midpoint of that plane. You're like, okay, you get the endpoint here, you'll still see it's going to say, if you look at the status bar, you'll still see it's going to say it's the endpoint of the column, but it's just going to be a little bit different when you start coming through going, oh, okay, wait a second, what's happening here? I didn't even pay attention, so I'm still doing W by 12, sure, whatever, that makes sense. But again, like here, it's like, oh, is it this endpoint? Is it this endpoint? Is it the midpoint? So it becomes a lot different when you're starting to select things to be trying to go through and say, oh, am I attaching this to this column? Am I not attaching this to this column? What's going on here? Because I'm getting all these different endpoints when I start snapping inside of here. Right? So just, oops, I hit escape. I did not mean to. So let me come over here, hit the endpoint, come over here, hit the, again, here's the midpoint. You start really, really, really becoming kind of bizarre on what's going on when you set this stuff up because you are working on that slope reference plane here. Okay, if I go back to 3D and I start looking at this in 3D, you can see that even though I said, hey, this is where we're going, you will see that, oh, it is understanding that that column is there because I did snap to it, even though I'm kind of, off base here on that column. It is still centered on it. It is still there, but it didn't really look like it when I was in plan because again, it's snapping perpendicular to that work plane. So it becomes a little bit deceiving or weird when you're going through and setting it up this way if you're pre-modeling it on that slope. Okay. I'm going to go through and say, okay, this is cool. And it's maybe to make my life a little bit less confused in what's going on. I'm going to go back to that section I was looking at. And I'm going to take these two columns here in the middle, and I still can attach these columns to a reference plane. So when you grab a couple columns, you'll have the capability to attach them, right? I can attach this column at its top or the base. So if I had a column on the level above, I could also attach the base to that, but I can attach columns to this reference plane, right? So I can attach it to floors, roofs, slabs, I believe, reference planes, obviously, and I think that's it. I could be, or other beams. I could do it to beams as well, but I can also choose the top or the bottom of the column. And then if it is going to be a column, you have the option of what's called the attachment style. Am I going to cut the column? Am I going to cut the target? Am I going to not cut it at all? And this is more when you start dealing with concrete or wood. If I was dealing with concrete or wood, I could actually have the top of that column get cut. So that way the wood column would be cut. That is not an option. You can say cut column, but it's not going to actually cut the top of steel. It only does it for wood or concrete. So if you say cut column, cut target, whatever, you have that option. Then you also have the option of when I attach it, is it going to be the center line of that column that gets attached to it, the outermost edge, the maximum height? So if I'm looking at it here, the high side, or the low side, when we look at it, the maximum or the minimum, right? And then if you are attaching it, you can even come in and say, hey, attach it, but give me an offset. So if I wanted to have like a 1/2 inch plate, if I was attaching this column to the underneath side of the beam, and I was going to put a 3/4 inch plate in there, I could have the offset be 3/4 inch. So you do have all those options when you're doing an attachment for columns, and then you're going to pick what you want to attach to. And you'll see it does come through here. It does attach the column. And now my beams did become shorter because they understood that, oh, okay, here's my beams. I've got to go through and let the column reside through. Now, I did misclick on this side when I was doing it. So as I'm coming through and looking, it's like, ooh, I put those in there. But when I clicked the endpoint, I probably clicked the endpoint at the bottom and it was the wrong one. I believe this side I did midpoint. I believe this side I did endpoint. Again, not a terrible big deal because we can always come in here and do a trim single or trim multiple and start moving these objects back. They are associated to that plane. So it is going to still understand what that plane is doing. And actually, I lied on the scale, I guess I'm telling you. I told it to cut the column when I said middle. And as you can see, the top of that column did get cut. I don't recall that happening in previous versions of Revit. Maybe it has, and I just never noticed it. So I'm actually going to take this column just to see what happens because, hey, this is a surprise to me, actually. I'm going to take this and change it. Instead of cutting it from the column midline, I'm going to take the maximum intersection. And yeah, so it did cut the entire top of that column. So it's actually kind of cool for this. So we could do the same thing here. Again, as you can see, you can change it after the fact. When I attach to those columns, I can come in here and go to the minimum intersection. So it's not going to be cut at all, or go back up to that maximum intersection, or come down and say, you know, I wanted it to have a 1-inch offset if I needed to pull that down for a plate or something. You have all of those capabilities to start going through and setting that up. But again, I screwed up putting these beams in here. Okay, fine. But again, like I was saying, you can still go in and do your trim. So if I go to my modify tab, I can do any one of my trims. I can go do trim single, trim multiple, pick, you know, this side of my beam and trim this one, or column, excuse me, and trim the beam back, pick this side and trim this one to it. And now we've got that same scenario and they're all going to understand they're all still attached. Okay. So mess up, not a big deal, right? This is all Revit. We're all used to that. Again, I obviously screwed up when I did this one again. So I'll go back and do my trim single type scenario. Got to use my tab key. No, that's trim corner, trim single, grab this plane and pull this one back as well. Okay. Now, what's really nice about this, again, since I've attached these columns and I've got all my framing there, is if I go back into that section and I take this reference plane and I rotate it. So I'm going to grab my rotate. I'm going to place its base point at the end point down here, or maybe you wanted it at the grid, the column intersection, whatever. But if I take and rotate this down a little bit, I got to go turn my snaps off because it's trying to rotate full degrees, and we'll just go down and rotate this 2 more degrees. You'll see that all of this framing is going along for the ride. All right. I'm going to go hide grids real quick because I'm getting grids in the way. Hide the category. So you can see I did do this. These did still understand that I'm theoretically supposed to be attached to that column. So they did shorten and do what they needed to do. And we do kind of have that set up. So as we go through and start changing these, referencing this, it goes through. Now, if I wanted to go and start again, modeling some more beams inside of here, et cetera, obviously I've just got the perimeter beam. So if I go to my beam command again, and I now want to put a beam in here, snapping to the endpoint here, right? Still going to understand that work plane. I did make sure, sorry, I did pay attention to my status bar. So I still am set up to that reference plane. It's all still there. And I can still go do beam systems. So if I wanted to come in here and do a beam system, it's still going to understand that I'm going to do a beam system. Sorry. And I came in here, I'll do that again. So when I had to do beam system, it's saying the work plane can't be used. So even though I've got this reference now, the last level I used was the sloping reference plane. A beam system can be associated or can't be associated to a non-parallel work plane to the view for the one-click creation. So all that means is when I go to do this beam system, as opposed to having the automatic beam system where I could just hover over a beam, it's going to force me to go into the sketch boundary for the beam system. I can still use the pick supports and pick all my supports here. I can still go through and say, hey, I wanted it a fixed distance. I can choose the lumber I want or the material I wanted. Sure, we'll throw an HSS square. Do not laugh at the sizes. I'm just throwing anything in here. The big thing is when you go to do this, and it's going to be flat, and it really drives me crazy on this, is when you're sketching the boundary lines, you can't tell it it's 3D. It's really, really bizarre. When I'm using the pick supports, I can't tell it this is 3D. So when I finish this, it's, oops, got to go trim this up real quick. Just 1 second. So when I finish this beam system, the beam system itself didn't let me check it was 3D, but it understood it still had that work plane. So it's really bizarre compared to other beam systems. I'm going to do a beam system a different direction. The 3D box would be checked, but this one, it doesn't give it to me. It's really bizarre, but it still understands I'm associated to that sloped reference plane. So as long as you get into that slope reference plane and that's your work plane, you can't do one pick beam systems, but you can still go through and pick all your supports, etc. when you're doing it. So just for giggles, I'll go through and throw another beam system on here real quick. I'll use my pick supports. Pick supports, I'll pick all 4 supports again. Probably gonna have to trim this corner over here if I did before, and we'll finish. Oops, missed another corner, trim this one. And say finish. All right, so still got the beam system, still working great. Now, one advantage of using, or disadvantage, depending on what you're doing, if I start looking at this, you can see that when I use a sloping reference plane, all of these members become perpendicular to that reference plane. So it might make sense to have all these intermediate beams chosen to be perpendicular to that reference plane, but the problem is it's going to do all of them that way. So you'll notice that these ones are all going to be rotated at 5 or 7 degrees or whatever I have that slope in that beam. This might be exactly what you wanted, but if you needed one, like in this case, to be plumb, then you're going to have to start coming back and relying on that cross-section rotation. I think I was 7 degrees, -7 here. So when we start setting that up, if you did want your beams plumb, you're going to have to come through and determine, oh, well, I needed that one plumb, maybe I needed that one plumb and that one plumb. So I should be grabbing, not what I meant to do, this one here and this one here, and I'll grab those and say, hey, you know what? All of those needed to be that -7 degree rotation. Okay, so you do have that. That can be an advantage or a disadvantage, just understanding that's what it needs to do. The other disadvantage or advantage, depending on how you want to look at it, is if I'm in that view and I want, again, like you saw, rotate this, I want to change the slope. If you've used a reference plane, you have to come back and use the rotate command, right? Where am I rotating this from? Again, you might be doing it here. I'll come over here, just say, hey, it's going to be 2 degrees. And now I've sloped it back down to that 5 degree I was before. But again, oh shoot, go into wireframe. This one had a 7 degree value in it. The plane changed. So now I've got to go through and make that be my -5. So this, again, just trying to show you, it can be advantage, disadvantage, however you see it, what you're looking for, but all those beams are going to be perpendicular that are associated to it. Now, the other thing that I kind of find being a little bit iffy on something like this is I'm going to go dimension this first beam. I got to be in not wireframe or not this. I got to be in a medium or fine level of detail. I'm going to go dimension the edge of this and the edge of this to the grid line. All right. I'll also dimension just the spacing lines here, just so you can kind of see what's going on. So when I look at these, and I am going to tile my views real quick. So I'm gonna pull this one over and get my views tiled. If I can get my mouse to stop moving where I don't want it to move. There we go. So I'm gonna tile these up real quick just to kind of show you. So if we look at these dimensions here and we see that this is, 3'11" and 5/8. If I take this and rotate it again, I'm just gonna go rotate it another 2 degrees. What happens is these elements, as you rotate them, those numbers try to stay 3'5" in plan, or whatever the value was in plan. I probably should have did a dimension in plan. What starts to happen here is these try to stay that given distance away. So as I keep rotating this value here, I'm rotating another 2 degrees. This 3'6" and 7/8 stays. I'm actually running because I'm not rotating from here, so I'm detaching this. But as you can see, this tries to stay 3'6" and 7/8 from the end, but in plan that rotates it. So as you start understanding what's going on, is your plan dimension isn't going to necessarily match your slope dimension. And doing it this way, what it's doing is trying to keep this value maintained. That's, the value from the edge as opposed to the value from the beam. Obviously, as we rotate that, that number is going to start changing. Okay, so just understanding that's what it's doing. Again, you may not care, just understand that relationship as you start going through. Okay, so question did come up. Is it possible to slope the reference plane after placing the beams in level view to avoid midpoint discrepancies? Yes, absolutely. You could have modeled this all flat, so you're not running into the whole weird midpoint issues, etc. Then you could go through, rotate the reference plane after the fact and go through and set up. Like I said, you saw that I rotated this. I was just grabbing it and saying, hey, rotate. I've undone a few times. It is critical that when you are rotating this, you're like, hey, let me pick the end of this column or whatever to make sure you're maintaining whatever that slope relationship was. Maybe you had a level there and I should have been rotating it from the level, who knows? But that's just where you've got to make sure that you are rotating this, you are setting it up from its, sticking point when you do it. But yes, absolutely could have modeled it all flat and rotated it. But again, had you rotated that after the fact here, this value, you would have been like, oh my God, this value looked like it was 4 feet away. Now it jumped to be 2 feet away, obviously, depending on the slope, the rotation, etc. So the only other option to this that's very similar, going down the same path, is the reference point, the modeled element view. So I'm going to go into the modeled element. That's my elevation where I chose like the underneath side of a modeled element. So you can see on this side, I've got the same slope framing, and over here, I've got it too. But this time what I'm gonna do is I'm gonna take my deck, right? So I've got this lightweight metal concrete floor here, but I wanna use the underneath side of this. So rather than doing it as a reference plane, everything that I just showed you is gonna be exactly the same except for one thing. I have to go into a vertical view again, a section or an elevation, whatever. And then I have to come up here and hit the set button. I am in Revit 23, so the slight difference here is the set work plane button is actually a drop down. Prior to this, you had to click just this button up at the top, come in here and say pick a plane. New to 23, they gave us the option just to say, hey, I want to pick a plane right here. So it's the only difference. If you're in 22 or prior, the only difference between what I'm showing you now and difference is the way to set the work plane. So I can say I want to pick a work plane, and I can choose the bottom side of this slab. And when I do that, Revit's going to say, yeah, that's a perpendicular work plane to this view. You have to be in a view that's somewhat parallel to that. So it's going to tell me I can go to that floor plan view. So I do have to say, if I want to set that work plane, which view do I want to go to set that work plane? So cool. Now I'm in this work plane view to set that up. So I've got this other version over here. You can see this is the roof I'm choosing. It said no slope. And now when I go do beam, kind of what the person asked before, can you start flat and rotate it? We're going to go ahead and do that here. You'll see that up here, it's telling me that placement plane, since the current work plane was the underneath side of that floor, it's there. If I switch this to be level 2, it'd be like, cool, let me model a beam on level 2. And then I go back to choose that work plane. That floor, again, is no longer there. I'd have to go through the process of going into the section view or vertical view, hitting the set work pick a plane button, and then boom, going back to my level 2. Again, now when I do the beam, my reference or my placement plane is going to be that. So pretty much the same thing we did, except for the fact that like question came up, hey, can you do it flat to start with? Yes, I can. Now I can come over here and choose the end of the wall, go through here, cool. Right, so everything you saw me just do, I'm doing the exact same scenario. I'm just doing this all flat to start with. I'm gonna go do my beam system, just like what you guys saw me do here a minute ago. Again, since the work plane is in a level, I am getting this same scenario of, oh, you can't do the one click, pick, click. Cool, I'm gonna go pick my 4 supports, hit finish, get that in there, do the beam system again, do my pick supports, yes, I know. Pick supports, pick my 4 supports, and finish. Cool. Now, one advantage of doing it on the underneath side of a deck like this is now I can just grab this roof and define the slope, right? So when I modeled this floor, I'm going to go and say edit boundary. I did choose one of my sketch lines and say, hey, it's going to define the slope. So in my floor, I had this is going to be where the slope is being controlled from right at this point. So I said, hey, give me one of these as a sketch slope. So now, rather than having to go into that vertical view and rotate it, since I've got this roof as being defined as a slope, I can go put that 5-degree slope on, boom, it's gonna go through and say, hey, look, now we're sloping. Make it a -5 degree if I needed that to go up, whatever is gonna be true, unjoin, and then it's gonna come through and set it up. Just like with the reference plane method, I can grab, delete this one little beam, I can grab all of the columns here, get rid of my grid lines, get rid of my wall. I can grab my columns. Oops, that was the wall. Needed them over here too. And do the whole attachment method. I'm going to attach. I'm going to grab it to the floor. Same all options you saw before. I got to unjoin these, but boom, here you go. Now you can see the column is still running through the beams are getting cut, etc. Again, if I change the slope of this roof to be that -7, whatever, cool. It sloped it, everything updated and went along for the ride. All right. I do have a wall here. Walls can also be attached. We do not have the options, which I don't know why Autodesk has not given this to us. I would love to be able to see the same cut the wall, have the, or not cut the wall, because it automatically cuts the walls, which drives me crazy. And then I'd also love to have the offset option. But if I do attach that wall, it always is going to cut the wall. You don't have a choice in the matter, and it goes through without the option. So yes, very similar. And again, the same scenario I said before, if I go into wireframe, all of these beams are going to be perpendicular to what's going on there. So you can see this beam's perpendicular. Again, if you wanted to change that, you'd have to put that 7-degree cross rotation or negative 7-degree cross rotation. You'd have to go through and start setting that all up to see what's going on there. Yep, that's the right one. So kind of the same scenario. Go through, hey, I've got to do this. So again, might be great if all of these needed to start going through and being, perpendicular to the work plane, but you might not want to model all of these beams that way. You might want to go through and model these beams where you're just being on level 2 and play with the offsets. Okay. So the next option I have is what I like to call the attachment method. Oops, looks like I might have accidentally already modeled all of them in my attachment method view. Dang it, I guess I'm gonna have to come here and delete these out. So no, that's reference plane. Here's my attachment method, but yep, it's all still modeled. Dang it, see what I did? And grab this beam system here and delete it. Let me grab this beam system here and delete it. And then let me grab, I guess I can just use my selection window. Let me grab all of the structural framing and delete that real quick. Okay, so my method doesn't involve either of those. I'm going to go back and full screen this. So my method doesn't involve any of that. My method is to do everything flat. Okay, so what happens here is when I say do everything flat, I'm not going to associate this to any work plane or anything set up like that. I do need to get back to my level 2. I was like, why is it giving me the weird midpoint snap? So you do need to make sure I'm on my level 2. I suggest, and this is me again, there are upsides and downsides to everything. You might think this way is completely terrible. I'm going to come over here. I'm going to deliberately leave that short for a second because I do want to talk about something here. And I'm going to come in here to the midpoint here, and then do the exact same thing we just did. Now, one of the beauties, and this came out on, I don't remember what release it was of Revit, but I could not believe that they were not making a huge deal about this. I'm going to grab this beam over here. This beam is associated, I picked on that column. When I placed this end I left free floating. So the start end is at the column, the end is floating free. When I come over here and look at this, what you're going to see is that there is this start attachment. Well, my end attachment shouldn't have been associated. Maybe I did pick on something. Pull it back. There we go. So my start attachment I have a start attachment type. I do not have an end attachment type. If I come over here and grab this one, you're going to see I have both a start and an attachment. So if when you're playing or putting in beams and they are associated to a column, this property will show up. And what this property means is if there is an attachment, and you'll see if I hover over it, it's a start attachment type. This is built in. It specifies the attachment orientation to the start position of the beam. Cool. That doesn't tell me what it's going to, but at the bottom it says, oops, can't move my mouse. If I let that tooltip expand out, it says distance orients the start position to the join location of a column. So the reason I get this is by default, it's saying don't attachment, just use whatever elevation I plug in here. But if I change this from end elevation to distance, notice that I now have 2 new properties. This new property is going to be the start attachment to the reference column, the top or the bottom. So depending on if you were doing like a hanging column or whatever, I obviously want this to be at the top of the column. And then what is my attachment distance? I can have it go to the top of the column, but be 6 inches down. So I'm going to actually grab these ones here because they all have both values. And I'm going to change both of them start attachment type to end elevation, or excuse me, to distance. And I'm going to change this one down here to distance as well. Now, what's cool about that, I need to be in this one here. I'm going to hide my floor real quick. If I take this column and I go to its top offset and I move it up, that framing goes along for the ride. So we can have all of our beams move with the columns, right? I'm going to undo that. So if I was trying to do this same framing here, and even though I was going to be next to a wall, the problem is if I draw this to the wall, I'm going to go model this up to the wall. I still don't get that end attachment. In this case, it would be start. I don't get the start attachment because it doesn't do this associated to walls. It only does this if it's associated to a column, right? So what's beautiful about this is I can then do all of this. And what I showed you a second ago is I can attach these columns to the floor or reference plane, regardless. And when I do that, the columns are going to move. And as long as I've set all of my start and end attachments from to distance, they will then go along for the ride. So what I've learned in a scenario like this is that's cool. I really want to do this, but I'm going to go in here and put in a column anyway. Right, so I'm going to come back here and go to a coarse level of detail. So you're going to see I've got these two little orange dots, these orange columns, these orange lines in here. This is technically a column I have modeled in there. This is my own column that I call a reference column. There's no 3D geometry into this family. It is just a symbolic, or excuse me, a symbolic line built, a model line in there that only displays in coarse. So if I go back to a medium or a fine level of detail, it disappears because it's only going to display in coarse. So technically, I have columns inside of here. Even on the floor plan, if I come back, and the reason why this was screwed up a little bit, if I do a selection window here, you can't see it because it doesn't show up in plan, but there is a column going to be there. So a lot of times when I'm starting off on something like this, I'm going to take those two, I'm going to switch these two reference columns just to an 8x10, just so I can see there's something there. So I'm still going to come in here and trim and place these two beams to these columns. And I'm going to again go in and place another beam inside of here. Go beam from the midpoint of my column to the midpoint of my column. Right. And then I'm going to grab these three and also change the start and end attachment to distance. I'm going to go put my beam systems in here. And since I don't have a different work plane set up, the work plane is the level, it will let me do the automatic beam system. So now I can just place a beam system there, place a beam system there. All right. Now here's the beauty of this. If I go into now the elevation view where I've got this set up over here, I'm going to go hide grids again with my sunglasses. I can take all of these columns and attach them to this roof, right? Again, you can do the cut column, midsection, max intersection, all those same options are still there, but I can attach those to that roof. Now what's beautiful is if I select this roof and be like, oh, that needed to be a 5-degree pitch, all of the columns go along for the ride. The beams are associated to the columns, they went along for the ride. The beam systems are associated to the beams, they went along for the ride. So as I start to look at this and play with this, you can see my beam system is still saying, hey, theoretically, my definition is up here, but this beam system is associated to the beams. It all goes along for the ride. So for me, I do this as an attachment type. I model in my columns, I model my beams to the columns, I change the attachment type, I put in my beam systems. And now as things start to slope and start to do what they need to do, this will all start going along for the ride, right? Now, the downside of this, like I said, is you might not actually want a column right where the wall is. And I've modeled these out past the wall itself. So again, this is where I have my families, where I've called these families my reference columns. So if I go swap this out to be my reference column, nothing will display. It's going to say, hey, this was joined. I'm freaking out. Oh, why did this one do that? My reference column. I don't know why this beam, I lost this beam. What is this beam? Oh, that beam's part of the beam system. It's just outside of it, it's fine. So I'm gonna take this in beam down here, that's not part of the beam system. And I also have a reference beam, which does the same thing, right? So I've still got the reference beam, so the beam system can be associated to the beam, and I've got these reference columns in here. Again, now what I can do is take these two columns and move them right next to the wall, get them to be associated to the face of the wall. This solves two things for me. One, I'm going to be able to start getting this attachment type and everything going through where it should be going. But two, what I can do on this is now control the cut lines of these beam system, right? A lot of times when you use the wall for the beam system, people will freak out. It's like, oh, I wanted this beam to be a little bit farther or this column to be a little bit farther. Cool. Take that column you have and move it into the wall or outside of the wall. It's nothing you're actually going to see, but you can go through and start taking that and moving it and going through and seeing what's there. Go back to course. So I can get in here and grab this. Again, now I'll go to course. I'll get out of thin lines, and you can see now I've got this beam line where I wanted it to go. If I wanted it to be into the wall a little bit farther, I can grab that column and move that column, or I can pull that column back or do whatever else I wanted to do. So I can start setting that information up and doing it the way I want. And I use this method quite a bit, right? So again, back in 3D, I'll never see it. There's these little beams. I moved it over. I am going to grab this beam system because there's this one beam that's like probably right on the column line. I'm going to edit the boundary. I'm going to say reset to see if it'll fix itself. Finish. Ooh, no, now it all went vertical. Oh, because when I reset it, I forgot to check the 3D button. And now finish, and there we go. So this is also something that's very bizarre to me in this scenario is notice how I'm gonna undo a few times. So I came into this beam system and it was sloping all but this one. There's this one weird beam. Oh, it's because I unpinned it. No, it's pinned. There's this one weird beam here not doing what it needs to do, right? When I grab the beam system itself, which is gonna be up here, in a beam system, there's always the potential to say reset. And when I reset this, all of those beams went flat. And this is really bizarre to me, and I don't understand why this happens. It's because this beam system doesn't know it's 3D. If you check 3D, all of the sketch lines will let you know, oh, I'm going to be associated three-dimensionally to something. This one over here is not 3D, but it's sloping. But for some reason, if you hit reset, it makes it all go flat unless you check the 3D button. I've not figured that one out yet. But if I go reset, do it, now that one beam that was this last beam that was floating is now going to be sloping with everything else. Same thing with this beam system. I'm just going to go make sure it's 3D so it doesn't glitch on me as it goes through later. Okay, so this is kind of my theory when I start going through and doing all of this. And I'll do the same thing. Like if I've got beam cantilevers or anything like that, I might model a beam, a reference beam way the heck out here, just so I can get that reference beam to be doing what I needed it to do. And in that case, I'm thinking more like residential, where I want rafter tails to go out or something like that. I might be using this reference beam family. Or often, I'm going to edit this beam system up here. I'm going to change the direction of this beam direction. I'm going to make it go this here. So a lot of times I really, in plan, when I'm in my course level of detail, I want to control, do these lines go in farther? Do they come out farther? What's going on with those? But again, if I had all these reference families inside of here, I could move that reference beam in or out to control my symbology on how far that's going to cut back or go forward. Because a lot of times it's like, oh, these go into the wall, or I need to model these going over the wall because they're sitting on top of the wall. But I use the wall for the beam system or anything like that. By using all of these reference tools, I can pull that beam wherever I wanted it to and start controlling that scenario. So the question did come up is when I am going through and attaching all of these elements to the roof, can I do it to the architectural model? Unfortunately, no. I can't attach columns or walls to the architectural model roof. What I always suggest, and I'm going to show this next, is I always like to go in and just copy their roof to the clipboard, paste it to my project, and then go through and use their roof, put it on a work set you turn off, create filters to turn it off. But that way I have something to do it. And if they change it, I just delete what I had, copy theirs to the clipboard, paste it same place, and then reattach everything to it. A little bit of a pain, but if you're talking something like I'm going to show over here, if you're talking something over here, then yeah, this is my architect's roof. I copied it from the clipboard, paste to the paste same place, right? So when you do copy, paste, same place, you'll get it right where it was. And then what you're going to see is I'm going to take all of these columns and attach it. So if they update the roof, if they change the slope, whatever, copy, paste, reattach all the columns, I'm good to go. So in my real projects, I go through and have specific views where all I'm seeing is the architectural roof. I've got filters to turn things on and off, and then I can just keep reattaching all of my columns. Now, in this case, where I'd be coming in here and looking at this, you will start to see, again, it's kind of looking more like maybe more of a residential type roof. I'm going to go in and get out of my course level and go into like a medium level of detail. You are going to see that I did put a column, and I just threw wide flanges in here. It could be anything you want, but I did throw a column everywhere I know there's going to need to be a slope. So I threw a column at this ridge. I threw a column down here. Like I said, if you were going to have rafter tails and you wanted to show the rafter tails, I would have put this column 2 feet out, right? I've got all the columns everywhere I know I'm going to need to do something. And I didn't need one here. but I did need one basically at every corner of every ridge and valley. So yes, I have one here, 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 etc. Now between those on the end, if I go back to a course level detail, I have my reference beam family. I'm going to hide the grid line. I have my little reference beam family here. So this is my reference beam family. Again, it's the same little orange line that I did model from this beam to this beam. Actually, it looks like I modeled that one all the way across, so I don't technically need this column. But I did model a reference beam going from there, a reference beam. So I did go through and start putting reference beams from every column to column scenario, right? If you wanted a ridge beam in there, cool, make that a real beam. I just modeled these to kind of show, hey, maybe there would be a ridge beam below this. And if the ridge beam was below it, then I'd model that independently of this. But I wanted all of these to go right up to the underneath side of the deck, right? Then if I go into this elevation called this one, again, now if I come over here, I'm gonna go hide my grid lines. I really should have made those taller. Go hide my grid lines with the sunglasses. But now all I have to do is grab all of these columns, hit the attach button, attach them to, I'm gonna go to the intersection in this case, attach them to here, and boom, all of those went along for the ride. I now just should probably do that. I'm gonna do it here. I'm gonna go to my medium level of detail. I'm gonna grab all these columns here. I'm going to say attach. It's more of an awe factor here. So all flat framing, I'm gonna attach it. All beam systems inside of my reference beams. Boom, there you go. I just sloped this entire project. So again, it was place all the columns, put my reference beams between all of those columns, put a beam system, say the direction of the beam systems, right? If I come back here and tab this, I didn't model each one of those. There is a beam system. I did make sure all my beam systems were set to 3D, and then boom, I go through and attach it. And now you can see I've got that all sitting there. And again, a lot of times I start with some sort of actual column because it's easier to see. But then once I'm done, I select them and swap them out to be my reference column. It'll usually tell me that I've got to unjoin a few things, and all it's telling me is, oh, some of these things were like these reference beams were cut in the middle by that, but there's no longer geometry. So, but it all still works. It's all still there. And if I take this roof slope and it's like, ooh, that's not a 15-degree slope, let's do a 22-degree slope, right? I change the slope. All of those columns are going along for the ride. The beams are associated to the columns with the start attachment and end attachment. And then if I go through, and there you go, my beam systems are then associated to that. So kind of a nice little scenario there, and to go through and do that slope framing. Now, the last method is doing something like this. So the architect modeled this crazy fun curved roof, and I now need to show a member going on that curved roof. And then I want to show that member on that curved roof every 16 inches. Well, the only way that I had found to do this, and this is a repeating curve, but let's say it was a warping curve. How I had done this in the past, I had copied the architect's model to the clipboard, and then I did a series of basically shafts every 16 inches. I did a vertical opening or a shaft, and I copied it over every 16 inches. And then, because when you do that, you can go through and pick edges of your objects for placing these elements, as long as they're on a grid line, right? So if I come down here, I'm gonna go to level 2 and just see what these grid lines, wait, I'm in Revit 13, I could have turned it on, but so this is gonna be grid N and grid M, right? So I'm gonna delete this one here, and I'm gonna go to grid M in 3D just to kind of show you. So I'm gonna go set my work plane here. I'm gonna go set my work plane to be grid M. And then I'm gonna go to the beam command, and you can use the pick lines tool. And then I can pick the underneath side of this roof, and boom, it's gonna put a beam there for me, right? That's really cool. But if the shape of this roof changes, so I'm gonna go edit the profile, I'm gonna grab the crazy spline shape I put here, I'm gonna say finish. Watch how that one updates, but this one doesn't. So I was constantly going in and deleting everything, repicking the edge, setting it up, going through and doing it. What's beautiful about this is not a beam. If I hover over this one, this is a truss. So trusses have the same attached top end or bottom that we have with columns or walls. So if I come back in here to my level 2 plan and I want to go in here, I'm not going to model a beam in this case. I'm going to go model a truss. I'm going to take this truss and draw it right, from here to here, like we did before. And I'm going to go to 3D and look at this truss. Here's my truss. And here's what's really bizarre is if I edit the family on this truss, and I didn't understand this in Revit, how I created this truss is I took the how flat truss family, I deleted everything in between. So I deleted all the diagonals. Technically, I could even delete the bottom chord on here. So I deleted all the webs. I deleted the verticals and the diagonals, and I could even technically delete this, but that's it. I took the how flat truss. I believe I deleted all the other reference planes and things out of it too, but I deleted everything out of the middle and just have a top chord and a bottom chord. That is it. The most sophisticated family ever. You edit one, you delete it, you do a save as. But what's cool about it is when you place a truss, there's an instance-based checkbox to get rid of the bottom chord or top chord. I'm gonna get rid of the bottom chord. And now that there's a truss there, I can take this truss and say attach, pick the roof, and it now goes along for the ride. Downside of this is if we wanted to do like a beam system with this and place these every 16 inches or something like that, we could not use a truss as part of a beam system. So yes, you would have to come through here, grab your array, grab your copy multiple, whatever you wanted to do here. That is not copy, that is rotate. Grab my copy multiple, be like, cool, I wanted to do these every 4 feet. So I'm gonna come down here and go 4, 4, 4, right? I would have to do this, but the beauty of this is they don't attach. It's kind of frustrating. And if I grab more than one truss at a time, you filter out, just grab trusses. I still can attach, just like the columns, more than one truss. So I do have to copy them. I do have to grab all the trusses, but I can attach them. Again, kind of a pain. If you change the spacing from 4 feet to 6 feet, it becomes more of a pain. But what you can see is there again, now if I go edit the profile of my roof and change it, whoop, finish it, all of those will start to go along for the ride. Okay, this is a tip I learned during one of my presentations on this. Now, working with this in reality, when you start going through and setting this up, and it doesn't matter what type of member you have at the top. I have this as wood, it could be steel, whatever. It can even be concrete. You're going to do too much of this in concrete, but it could be concrete. But the downside of doing this is there's a few limitations. If one of those trusses is longer than the roof, back to 3D, I will not be able to attach this truss to the roof. It'll say, yeah, that's cool, but it's bigger than the surface. It won't let me do it. It'll look like it's going to do it, which really irritates me. It's like, okay, let's go attach this. Let's do this. You can see the cord is doing it. It's like, sweet, you did it, but you did it. But it tells me, no, it can't. I don't know why it says as an invalid. Oh, it could be because I dropped below here. Let's try changing the base offset of this real quick. Because maybe there's something new in 23 that I truss height's 10 foot. Let's go, where's my Z level? Let's just go make this -5 feet. I just want to get it down in a second, just to make sure that's not what the problem was. So now the base chord is below that. Let me try attaching it again. Yeah. So if the truss is drawn longer than the object, this will not work. So it's kind of a downside to this. You can't get it to be longer if it's drawn longer than the object. It can go diagonal through it though. So if I come back here just to kind of see this, if I even did this truss diagonally, as long as it's within the extent of what you're attaching it to, attach to this roof, it will let me do that. So I can start getting into some more crazy framing scenarios, which don't even ask me how I would ever try to figure out what this is. A curve on a spline, a diagonal curved object on splines. So it's kind of what we start going through and getting that set up. So the downside to doing trusses is you can't use them. You can't use them in a beam system. Advantage of doing trusses on something like this is you can go through and set this up and start getting it to work. Now I'm going to actually delete all these intermediate ones. That's my crazy truss. There's this one. Now, one of the advantages of doing this now too, and what's something that's really, really cool on this is I'm just going to go ahead. I'm going to draw a beam across the endpoints of this. So I'm going to go to my floor plan. I'm going to model a beam. Yeah, for here. Let me get rid of this. Let me hide this. Yeah, this is where I'm working. I'm going to go to model a beam. So I'm going to go structure beam, not the reference beam. And since we're using 2x, I'll choose some sort of 2x, whatever it is. I am going to turn my 3D snapping on because I do want to snap to the endpoint of this one. and then technically to the endpoint of this one, but I'm gonna go into medium because I think it extends out, doesn't it? Ooh, I thought this truss was longer. Let's pull it out just so we can see here. Okay, do this again, beam, that's wall, not beam. Make sure my 3D snapping is turned on. I'm gonna go to this endpoint, to this endpoint. And then same thing here, I'm gonna go to the endpoint of this and the endpoint of the cord. And the only reason I'm doing this, I just wanted to get some sort of beams in there, right? Now, if I go back to level 2 and I go do a beam system, automatic sketch, I do want to check the 3D button to make sure the 3D button's there. I'm going to turn off the walls define slope. I'm going to go ahead and do it this direction. Sweet, they're going to be even angled. That'll be even more fun. I'm going to do this beam system. I'm going to go to my 3D view. So what's also cool about this is even though I'm doing the beam system, it's picking the beams that are on there, and it's still going to understand that now whatever I do in that beam system is still going to follow what's going on. So even if I come back now and edit the footprint of this roof again, edit the profile, change this slope again to something bizarre, finish that. Oop, my trusses broke. Let's go make it taller. Trusses shouldn't have broke. Let's cancel this and do it again. Yes, cancel. I might have went below the curve of the truss, so I'm just going to edit the top one. That's the other thing is if that's another disadvantage of using the trusses. If the sketch goes below the truss, then it will do it. So usually I'll put my trusses like on level 1 and then just go through and set it up. But as you can see now, I've even changed the slope. The beam system goes along for the ride and it does it this way. So I have had people tell me that they'll do something similar to this. Well, they'll literally just come in and model like a truss on this end of the roof and then that end of the roof, and then they do a beam system between the truss. That's another option to go through and set it up. I still prefer this attachment method. But if you wanted to, you could do the truss with only a top or bottom cord. As you can kind of start to see, that's my definition of slope framing. So we did have another question come up inside of here. And the other question is, it's kind of unrelated to this, but in 2023, if you copy a roof from the architectural length model and place it in the same place, will it bring a roof type in that does not currently exist in your model? That is correct. So anytime you do a copy paste, and this is in all versions of Revit, if I had a linked model and I tab selected to get this, and I did a copy to clipboard, and then I said paste same place, it is bringing the definition of whatever that object is into your project. It's the only way I know to do it. You can't copy monitor roof, so it's not like you'd be able to copy monitor to the roof, bring it in, then turn off the monitoring. Can't do that with a roof, and you can't, because during copy monitor, you can say, hey, even though I'm going to copy theirs, replace it with mine. You can't do that. But again, not a huge deal. And honest truth for me, if I'm using this as a work plane, a lot of times I will leave it with the one the architect has. I might rename it and call it arch in front of it, or in the type comments or somewhere, put the term arch in there, and then I have filters that turn those off in all of my views, so I know it's an architectural roof that I've copied over. Some people put those on work sets. I'm not a big work set fan for visibility purposes, so that's for me. But yes, if you copy and paste from the architectural model, it is going to give you the type of roof that they had in there. So I believe, go back to my old PowerPoint slide, beam column associativity, I showed all of that. Oh, the one thing I did also want to talk about, I kind of forgot about this one. We'll go back to Revit. When I was talking about, you have the attachment types, and then there was a distance. I did forget to say this. Which one did I do that on? Is it this one? Let's just go hide all the roofs, hide the category with my sunglasses. That's end elevation. Is it this one? Oh, it's this one. So on this one where I came through and I did say there's, I'm going to set it up to distance, and it is to the top of the column. You can also come in here and have distance values. So if you needed to be like 2.5 inches down, you can do that. So like, hey, I always want you to move this object. Let's go make it a more grand value. So I always want you to move with the column, but I want you to be 2 feet down. It's like maybe you were even going to have something, you know, where these two were going to be that negative 2 feet down. Oh, they're attached. I can't move them up or down. They're there. But if they were going to be set up, I could move them up or down, and you needed this one to still be level going across. Absolutely, you could set that up and do it. But again, it's still going to go for a ride. Let me just detach this from everything. So if I take this one and move it up 2 feet, 4 feet, 6 feet, whatever it needs to be, as I do this, you'll see that this column is going to stay attached to it, but just 2 feet down. So when you do the start attachment, value and you change it to distance, you can also then plug what that distance is. Or like I said, it could be changed to the bottom of the column, which is now going to adjust that based off of the height of the column. So it's now 20 feet from the column, and it'll stay associated to the base of the column. So if I change that top and move it up, this is going to stay where it is. But if I take the bottom, and move it up, I missed it. Try doing a 10 feet, and it moves up. But if I take the bottom and move it up, then this will move with the bottom. So terrible example in this scenario, but if you are using it as like a hanger column and you've got the beams there, you can have it move up and down to the base of the column as well. All right, and that is my presentation. So only had a couple questions come up as we went through and did all this. If you have any other questions, speak now or forever hold your peace. Other than that, I really appreciate everybody coming in, and I am going to do one shameless plug, which I did not have inside of here. For those of you who all haven't been there before, I do a monthly webcast called Revit Radio. It's where you guys can ask me any Revit question and I answer it live on the spot. So if you're plugging away working and you want to be like, man, I just keep having these issues or a lot of times you'll just sit there and learn things from all the questions everybody else is asking. So it's something I do the first Tuesday of every month. So we will be coming up on next Tuesday. I can't believe it's the first Tuesday of the month already. So on Tuesday will be one for you guys to get on. So if you go to my website, bdmackeyconsulting.com, or Google the Revit Geek, you'll see Revit Radio, and you can click on the registration to get there to go through. So that's my shameless plug. I'm gonna bum Justin in here, see if he has anything to add for ATG or anything you guys have coming up at ATG.
No, I think that pretty much covers it. Thank you so much, Brian. If no one else has any questions, I guess we'll go ahead and shut it down.
I know, I got 4 minutes left. I never end early, but I guess 4 minutes isn't too bad. All right, thanks everyone for attending, and I hope you picked something out of it and you're able to jump off and use this on your next project. Thanks for joining.
Thanks so much, Brian.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.